and second last presentation of the day. Here is Tim van Helsdingen, and he's going to go over, what? Did I say it wrong?
Huh?
Nothing. We're going to go over the scene that he worked on from Houdini 19, and he's going to talk about Karma XPU.
You're spoiling it.
Oh, sorry.
Okay.
Goodbye.
All right, everybody. Welcome to a presentation, Level Up with XPU. Thanks so much for coming here with all the other cool stuff going on. Wait, was it? Okay, doesn't want to go to the next slide. Let me just do it with the mouse. All right. My name is Tim van Helsdingen. I'm a freelance CG generalist, Houdini FX artist. Work for a bunch of studios as a freelancer, and I also make tutorials, which you might know me from. I've been doing those for like 6 or 7 years. So if you've been trying to learn Houdini, there's a big chance you've come across some of my tutorials. And this was me when SciGRAPH asked me to come to SIGGRAPH, because I always kind of wanted to go at some point. So this was me doing a little dance. I'm going to talk about a thing I did for Houdini 19 launch, which was SciGRAPH Snacks version 2, Mojito Magic, which is sort of a fake commercial type thing, which originally was meant as a sort of a demo scene for the for vellum fluids, which was a feature in Houdini 19. And I rendered that in Karma at the time, but it was Karma in CPU mode. And now with Houdini 19.5, there's a lot of improvements to XPU, which is the sort of the GPU version of Karma. So they asked me to render it with XPU and add a little bit of XPU flavor. So let's have a quick look at the shot. So you actually kind of know what we're talking about here. So let's play that. All right, so I'm getting thirsty already, but that'll have to wait, I guess. So I'm going to talk in my presentation about sort of general improvements in XPU and Karma since last year's release. So some of the features that I'll be discussing already made their way into Houdini 19, because they've backported some of the features to Houdini 19, and some of the stuff is completely new in 19.5. So it's going to be mostly just about my experience first working on this shot in Houdini 19, and then all of the improvements that have been made up to this release. Why didn't I use XPU last year for this thing? Because it was already available. Like in 19, there was an alpha version for XPU, but it was very limited. It's really cool that they introduced it and have had people play around with it, but there was just a lot of features still lacking. And I tried it initially, but it was like very early alpha when I was working on this thing. So I quickly decided I should probably just stick with CPU, so I could actually be sure that I could render everything in time. But with 19.5, everything went to beta. So still not completely full final release, but beta has a lot of improvements over the previous one. So let's compare the one that I did last year with this one. Of course, it's the same sequence, but just rendered with XPU instead. On the left is the one from last year, and you can see there's little differences in the way they look. We'll go over why that is in a little bit, but in general, it's the same. It's the same sequence, and I was actually surprised that I was able to actually get everything through XPU, which is I think saying a lot. And yeah, I know the glass here is rotated. I noticed I forgot to transform node there after I rendered the whole thing. So, but I mean, aside from that, it's the same thing. But yeah, last year I rendered this whole thing in Karma CPU, and I was just Karma CPU wasn't really that fast at the time. So here's actually what I had last year on the CPU side. So the thing on the left was actually the final render with a lot of noise. And I had to actually do a lot of denoising and add some bubbles and stuff to actually make it presentable. And this was even rendered at 720p back then. So and I had to upscale it because I was just running out of time for the Houdini 19 launch. But with XPU, I was, so especially for this shot, you can also see a clear difference in sort of visual quality in general. So you see, first thing, in the art, you see a lot of artifacting on the old one in the depth of field, because I didn't have time to actually get it through on my CPU in time. So there wasn't enough sampling in the Z depth to do proper depth of field last year, but now I could actually fire up enough samples, so you have a much cleaner result. And another thing you might notice is that there's like the bubbles look a lot nicer. So because of the sort of the additional just render power that I had, because I could actually throw this through XPU. So here's just from the documentation, just some new features in XPU. So last year, for example, subsurface scattering wasn't available in XPU, so that was kind of a thing that kind of needed. There was no point rendering. You couldn't mat out objects. There's a lot of stuff missing that I actually ended up using in the CPU render. But let's talk a little about the sort of the differences that you have, because they're actually sort of two different render engines, which use the same scene. So you can use the exact same scene, exact same lights, exact same materials, but you actually switch between the two, and both have sort of pros and cons. So CPU has more features for now, because generally they will develop features on CPU first and it will backport them to XPU. And CPU for now has a little bit more options to tweak, for example, for sampling and stuff like that. And as of right now, it's a little bit more reliable, but of course XPU is still in beta, so stuff will keep improving. But of course the big downside is it's quite slow. While on the XPU side, it's a lot faster because you can use all your devices, not just your GPUs. You can also use your CPU, which also helps. Like, for example, if you're working at a studio which has a CPU render farm, for example, you could just have your artist work on the XPU side and then still farm it out, and then the farm will just pick it up on the CPU node. So it will still render. So it kind of depends on the type of production that you're going to do, if you're going to pick doing this in CPU or in XPU mode. And it might be good to sort of pick that early on, but we'll get into that a couple slides on. So CPU you might want to do for, or if you're doing really heavy sort of VFX or animation workflows with a lot of assets, it's just going to be really heavy scenes. If you need a lot of flexibility, which like your sampling and lead like AOV settings, stuff like that. And XPU is, for now at least, probably going to be better with lighter scenes without a lot of assets, and like maybe some simpler like motion designy type of things. I'm not saying the motion design is always lighter scenes, just giving an example there. Because of course you're still tied to the VRAM on your GPUs, and it's going to depend on the GPUs that you have. So here so it's the same scene, and you can already tell that they don't look exactly the same, even though it's exactly the same scene, same material, same lights, and one is rendered in Karma CPU and one is rendered in Karma XPU. So they're trying to sort of bring together the way these look. I think eventually they want to bring it sort of parity with the look, but as of right now they do look a little bit different. So that's going to make it a little bit difficult to sort of use CPU maybe on the same shot. So you might want to decide early on if it's a shot that you could render in XPU or in CPU. Another thing you might notice is the render time, almost 17 minutes on the CPU side and 2.5 minutes on the XPU side. And so my CPU is a 3970X and the XPU side is two 3090s with, of course, also with the 3970X, because it just picks up all the hardware that you have. It's not a one-on-one comparison because sampling settings are a little bit different on CPU, and this is just the same scene. So I guess if you went through the CPU and you tweaked some samples, you could get this down. But I do think it already speaks for just the general speed improvement that you're going to get for something like this. Here's another scene. Speed difference here is a little bit less extreme. This probably has to do here with the fact that you're going to see that in the next slide as well. With the GPU render engine, will start rendering just on your CPU, and then the sort of once the whole scene is loaded into the memory on the GPUs are also going to fire up, and then it's going to start speeding up. And if you just fire up your RPR, it might take a little bit of time for the entire scene to be loaded in the GPU. So if you were to fire up the RPR for a second time in this shot, the right one might actually be faster than it's here. So there's kind of sort of these trade-offs. Here you can see a very sort of different, you can here see the sort of CPU side, it's just really taking its time, and on the GPU side you can already see it being, well, a lot further along. Especially, it's not super clear, but you can see on the right side, you see which devices are rendering. In the beginning, the GPUs might display as idle, and then they're loading up the content, and then eventually they will start rendering, and then you generally see big improvement in sort of like how fast your scene is rendering. So CPU versus XPU side, on the left you see all the sort of the render settings you have on the CPU side, and you have a lot more control there over, for example, just the quality, like where do you want to fire your samples. For example, you might, in this scene specifically, like it might make sense to fire more samples on specifically the glass, because that's the part that's going to be the most noisy, and you might fire less samples at sort of the environment. So you have all of those controls on the CPU side. On the XPU side is just brute forcing, sort of just race through the whole thing. But of course it's going to be a lot faster because it's going to use all your devices. So kind of depends on the scene, I guess, what you're doing. If you need sort of flexibility there, but as of right now, XPU there is with the sampling settings a little bit similar, a little bit simpler. So you don't really have a lot of things to take care of, which has both pros and cons, I guess. So how to render in Karma and XPU, just in general. Just a very sort of quick tip that I wanted to throw in here. So like if you've ever worked with Solaris, you already know probably this. But on the left, there's just the standard stage context where you build your scenes. That's how I rendered most of my scenes. But as of Houdini 19, there's also the sort of the Karma ROP, which is similar to how you had the Mantra ROP, just in the out context. If you ever tried to use that, when you press the Karma viewport, it's gonna have this pop-up second window, which I find really annoying, especially if you're working on one screen. It's just not super ideal. Want to have show you sort of a quick tip to get it more similar to sort of the Mantra render view, where you just have the render view and you press render and it starts rendering. I'm kind of hoping that SideFX will implement something like that, maybe in some future release where it's going to be more similar to that. But for now, what you could do is you could make a new network view, then lock that view to, for example, 9 or another number. So you can lock, just press the sort of the pin button. You can lock it to 9, and you would navigate into the Karma ROP, into your lab network, and then link your viewport to it. And then here's a video on then actually what's going to happen. You're going to do the whole thing, going to the out context, going into our lob network. You can see it's just essentially just a wrapper for a lob net. But if you then link your viewport, essentially you have just your Karma viewport just in object context. And then if you space 5 on the viewport, you could get just a regular render view in your object context, which is kind of what I would want with just a Karma ROP it's more similar to how Mantra was behaving. So kind of hoping that they're making something for that eventually, and sort of as a native thing. But for now, I think this is a good sort of solution if you want to work with Karma this way. So this is just a general tip for Solaris, I guess, not specific to XPU. But what if you want to render your shots in XPU? So last year when I did this shot, I actually set this up with principled shaders. That was the way that you would build materials for Mantra initially, but principled shaders are not specifically supported in XPU. They do some conversion under the hood, but it's better to just build everything in Material X. So Material X is an open material standard, which they're really building out in Houdini. It's really nice. It's a sort of a combination. If you have USD, which is of course universal scene description, also open format, combined with Material X, is going to be great for the sort of exchanging files also later between other applications, for example, which also have Material X support. So it's kind of good to get into the habit of learning to work with Material X anyway. And if you're going to do XPU, you need to build everything in Material X anyway. So somewhere in the Houdini 19 release cycle, they introduced the Karma Material X subnet, which wasn't available when 19 initially launched, but this got introduced a little bit later, which is nice because if you just have to have the subnet, you only find Material X nodes if you're working in there. So it just makes the material building a little bit easier because you're not accidentally hooking up legacy nodes in there. So here's just an example of just just a Material X node. It's just pretty standard sort of PBR shading. And if you want to if you don't know a lot about material building, just go to your principal shader, just look at the textures, look what they're plugged into, and then just make the Material X image nodes and plug them into whatever slot they are in the principal shader, and that way you can pretty easily recreate your materials like that. A thing here is that if you have regular images, you would put them with Material X image, and then if you have tiled images, it's actually a separate node for that, and you sort of pop out the tiling parameter and you link them up. Would be nice maybe in the future if there's some sort of a wrapper that has sort of a unified thing for that, but as right now, that's how you use it. And another thing that got asked by someone on Discord, and I figured I'd throw it in the presentation, is how do you use noises in Material X? Because they're not as straightforward as the noises with that you had previously, just with the principal shader. So if you have the noise over there on the left, you cannot just directly plug it in. You need to give it coordinates. So what you would do, for example, in swap context, you will make a rest attribute on it. So rest attribute is essentially just the position of the thing, and it would be a static sort of position which you could map stuff to. You would plug that into the position, and if you put a multiply in between and you put another parameter in there, you can use that to tile your noise. So you could have scale controls over your noise, and you could stack those to make interesting noise patterns. And I'm kind of hoping that maybe at some point they will do maybe some presets or something like some other render engines have. That would be cool. But for now, this is kind of how you use the noises. And again, if you're doing XPU, you need to do everything in Material X, so there's no using of the other stuff that was already there. So let's talk about some of the new features that XPU has that weren't there previously that I kind of needed in order to render this shot. Sort of point rendering and mats was something that wasn't available before. I think point rendering got introduced somewhere in the 19 release cycles. It was backported, I think. That's, for example, used in this shot. So you have the rain, and I have rendered the rain and the plants separately. So here you can see the final composite on the left and then the rain on the right. And if you look closely, you can actually see sort of a silhouette of the plant, sort of just in between the rain. Which is a very sort of standard thing that you would do if you just set up a render scene. You would mat out your scene, but that wasn't previously possible in XPU. And of course, if you have rain, you might want refraction sort of your scene through the rain if you're rendering it separately, because if you're going to composite these together, you probably want maybe some objects to refract to your scene. So if you have a render geometry settings and you apply it to, if you have your lobnet, you would apply sort of one branch, you would put the render geometry settings. You could put the holdout mode to matte, and it would essentially matte out the whole thing from your render. And you would do another branch where you essentially can say, like, okay, which ray types should be rendered. So if you exclude primary rays with dash primary, then it will only render the secondary rays, so refraction and reflection, and it would be hidden for all of the other stuff, which means it would refract to the rain but not be directly rendered. And then you could, like we have here, you could get something like that. So that was something that wasn't previously supported in XPU, and it's just a very common thing you would do when rendering. So that's definitely something that's really nice to have. Another thing, mistakes were made. So apparently my shot was used in the Houdini 19.5 release about Nestor Dielectrics for XPU, which is not available in XPU, but is available in CPU. So I'm not sure exactly how that happened, but I think it was that I got a really like a list of stuff that was supported in for XPU, and I must have read one of the features that was supported for CPU as an XPU thing, and then I rendered the whole thing, and I guess side effects thought, oh, this has Nestor Dielectrics. So I guess that somewhere along those lines something went wrong, but it's only available in CPU for now, and it's gonna be in XPU. I guess pretty soon, but or not pretty soon. I don't know. I don't know when it's gonna be there. It's gonna be there at some point. Now, if you're gonna be like, what are Nestor Dielectrics even? Let me still give you an example of what they are, because it's still very useful. And then you already know how to use them if you're gonna use them in XPU later. So here's just a simple glass with some ice cubes and some indeterminate liquid, which they're resting in. And it might look like simple scene, which it actually is, but if you're going to look at, for example, the wireframe, you might notice that the ice cube is intersecting the liquid. Now, if you're going to render this, of course, like how does the render engine know like which index of refraction, which material should it pick if where the liquid sort of penetrates the ice cube? And essentially what Nestor Dielectrics is, it's sort of like a render time Boolean operation. So here's just images from the documentation. So essentially it allows you to sort of do a render time Boolean type operation, sort of to be able to say, all right, if the ice cube is inside the liquid, then you should use the ice cube and not the liquid. So here's just an example of sort of I gave priorities there on the right. I just linked the sort of the priorities onto a null. I will show you how to do it in the materials in a little bit. So the lower the number, the higher the priority. That's different from some other render engines like maybe Octane or Arnold. I think those are the other way around, where it's the higher the priority is. So this is inverted. So in this case, the ice has the highest priority, then the juice, and then the glass. But let's say if you were to sort of put the ice higher, then it just completely disappears. So you can see how this can be useful, sort of if you're rendering stuff, to be able to say, all right, which material should be picked. So it's very simple to set up. You just put a Karma Nestor Dielectrics after your standard service. That's also, by the way, maybe something to mention. The Material X standard service, as of right now, I think is the only one that's supported in XPU. So there's a couple of other ones you can choose from, but this one is the only one that's supported for Material X at the moment. Anyway, you plug your material in, then you give it index of refraction, which you can pop out from your shader and plug it in so it matches, or you can do something custom if you want. And then you can just say the surface priority, and you would do that for every single one of your materials, and then you get your Nestor Dielectrics working. Again, not an XPU yet, but hopefully soon. So some other sort of workflow tips that I ran into. So I needed Cryptomats, but those are not supported as of right now in XPU. So I have a working sort of solution to create sort of more of a puzzle mat thing. So here's just a whole bunch of sort of just mats for things I was using. So in my composite, I use those to sort of grade some stuff. And since I already made this entire sequence, so I kind of wanted the same type of mats that I had before, so I could just reuse my composite. But briefly, I was using Cryptomats. If you don't know what Cryptomats are, by the way, they're a render pass which allows you to, for example, in Nuke or in Fusion or in After Effects, to sort of pick your mats after the renders. You would say, all right, I have my Cryptomat, I load it in, I pick, okay, I want to create a mask for my glass. You pick your glass in the composer and it will generate a black and white mask, which is super useful. Karma CPU is supporting that. XPU not as of right now, but I mean, maybe at some point like it'll be supported. But sort of the workaround I found for that was to create an attribute on sub level. Just call it whatever you want. I call it mat. You can call it cheese or beer, or like pick a nice name. You would load it in as primvar. So you have the use the primvar reader, which is similar to a bind node if you do just regular material building with the principal shader. So you use the primvar reader. We load the mat, and you have the Karma AUV node. When you plug it in, essentially it allows you to define an AUV. And now the hacky part, you plug it into a random slot that you're not using, because then the material is going to load it. I kind of hope that they are going to maybe do a sort of a custom slot for maybe AUVs at some point to just ingest data. As of right now, that's not there. So just plug it into anything that you don't use. And then it will ingest it. And then you can make on the Karma render settings, you can make a custom AUV, give it the same name, and then it will just come out as a black and white image. And you can use that as a mat in your composite. So for now, this is a workaround until Cryptomats are supported. And hopefully they will also do sort of a custom slot on the material, because this can be useful for other stuff as well, not just for these mats. So it would be nice to maybe have a custom slot for ingesting AUVs, like making custom AUVs like this. So device filled. So this is something that you might run into if you're using XPU, where if it runs out of VRAM, for example, or there's some other issue, then your GPU devices will display as filled. It will still render so your IPR will still run on your CPU, but the GPU devices will display as filled. I ran into this quite a few times, and then when I tried to get a screenshot for the presentation, I couldn't make any of them fill. So I don't know what happened there, but again, you might run into that at some point. So some things that I that I noticed in order to sort of work around that was what I found worked really well is just walking through your node graph. Because I think what it's doing, I'm not completely sure, but it's loading sort of stuff on demand as you sort of refresh it. So if you start at the top, it's going to load in those things. If you walk down, it's going to add those into RAM. And I found it's sometimes it might be a little bit more stable if you just walk through it and then eventually it'll render, or you can find out where the issue is if you have device failures. So that might be something you could do. AUVs will sometimes give some problems with it as well, so you might want to clear out your AUV, see if that is a problem. And if you have the device filled thing, just switch it between Karma CPU and XPU, and it will sort of reload the whole thing, because it will keep displaying the device filled as long as you keep it in XPU mode. So there's some things to keep in mind. Again, it's still a beta, so they will probably improve some of those, but these are just some workarounds. And another workaround is to just buy the biggest GPU you can, so you have a lot of VRAM, and it's probably not gonna happen as much. So for just other stuff, if you thought sort of the sequence itself was cool, there's a 20-hour free course on just the other stuff, the vellum fluid stuff. So that's available on the SIGGRAPH website. And there's another presentation that I did last year about vellum fluids. We're also gonna release, I think, the source files of last year's stuff with the sort of XPU settings on there. Those aren't available yet, but they will be at some point, and you can download those and have a look through that. So yeah, I've run 1 minute late. Oh no. Anyway, if there's questions, then I'll take questions. So that was the thing.
No questions.
Oh no. Oh, there's a question there. Oh.
Wait. Oh, I'm blind. Oh. It's the interrogation lights.
Hi. Is there are there any limitations on the type of primitives XPU renders right now? I mean, I'm not sure if that's something you would know. Like, does it render curves for hair data?
Yeah, it does render curves right now. I think if you can go back, there's a whole thing on the. Go back through the whole thing. There's have to go back really far here.
No worries.
Oh yeah, here Cadmo ROM curves. Points like maybe there might be some limitations. I don't like. Okay. I haven't run into any of those yet, but like I don't know if there's other limitations that it might not do. But in general, for the stuff I was doing, just regular geometry, just point rendering. That's all working.
Okay,
working fine right now. So
thank you.
Anyone else?
Oh, there's one over there.
Could you show your noise slide again? You mentioned it. It was a little hard to see back here, but you said something about bringing in your noise, or would you use the X material noise?
Wait, where's that one?
That.
Yeah, well, this is just the Material X 3D noise. There's a 3D noise and there's a 2D noise. The thing is just it's not super clear by default because there's no settings on on the noise by default for like tiling and scaling and stuff like that. So this is just how you set it up in order to sort of tile this and how to map it either to. Like if you map it to the rest position, it will just behave as a regular noise. But like I thought this was like maybe not clear to some people, and I had some people ask me about this, so I figured that's why I throw in sort of a slide. So you just have the noise, you bind in the rest position, and you can multiply the rest position in order to sort of scale your noise, like make it bigger, make it smaller, or like stretch it out. So that's essentially how that works. But again, like I kind of hope that they're gonna work a little bit on this to make it maybe a little bit user friendly, and maybe wrap some stuff like in a sort of more unified noise thing or something. Oh yeah.
Wait.
Oh.
Do you know if it works with Houdini instances?
I haven't tried. Well, I mean, like USD has its own sort of instancing system. So, like if you instance in Solaris, it's going to work with that. I think there's might also be some improvements there. I'm not sure, because when I did some tests last year, like I have the grass in the last scene that was instant, and last year my scene was completely crashing when I was demoing it in XPU, and now it is rendering. So I'm pretty sure that it's doing fine with the instancing and picking up on the USD instances, but I don't know any specific details on that. Apart from that, it is actually working. Oh, and also the ice scene that I have that was set up with a custom point instancer, because you have all of the small debris pieces which are also instanced. So that is all working fine. If you're referring to any type of other instancing, then I'm not sure.
No, that's what I'm asking about. What about like point attributes, or reading in attributes to the materials?
Yeah, so if you load it as a, so there's two ways to load things in your Solaris context. It's sort of as an object level or as a sub level. If you wanna, as far as I was using it, I was using the sub loaders if I wanted to extract attributes. Because then you just have a drop down, you can select the attributes you want to load, and then we'll bring it on as a prim var. And you have, in the Solaris context, you have a separate sort of spreadsheet type thing. You can see all of your prim vars that are being brought in. That's also what I'm doing with sort of creating the sort of the mats, where I'm creating an attribute called a mat, bringing that in as a prim var, and then I can load it into the material, into the material to do any of that. So you can load attributes like that. And what you meant by for the Houdini instances. So you mean the pack geometry on sub level, or?
Yeah.
If you bring that in, there's options on the object loader, on the sub loader, to make it native instances. So you can set it up as a point instance, and it will convert it into native instances. So that should all work. There were some problems with that I had some problems with it last year, but I tried this, and now the automatic stuff seems to work fine as well. So that's yeah.
Thanks.
Anyone else? All right, that's a wrap.
Ooh, time for beers.
Yeah. Thanks, everyone. Thanks, Tim.